Entonces, in this moment, I suppose que you see the whiteboard, correct? Okay, entonces we start the last chapter, que es for the test number 4, and that's it. Okay, remember we have option on the final. Pero no, so you get one grade, can you consider it good for you? Maybe A, B. You don't need to take the final. The final is always to improve the test. Pero okay. This is not important now. The important now is the topic today is about one-to-one function and inverse function. Let me explain in detail this idea. Look, let me recall something. Recall the idea for the function that we studied in the test 2. We have different possibilities. This is domain, this is range. Suppose element inside the domain, que normally is x, x1, x2, x3, associated with the y1, y2, y3, in that direction. Okay? And this association is called F. This is classical one-to-one because one value in the domain is associated with the only one value in the range. But we have another possibility, que is like that. 1, 2, 3, 1, 2, 3. Again, x1, x2, x3, y1, y2, y3. Entonces we have, for example, you associate this, but I change a little bit, associate this, and associate this, and y2 stay alone, for example. Domain range. This is many-to-one. Many-to-one. This and this is a function. Because remember, the most important thing is 1, according to the definition for the function. The only guy gets no function is when you have that situation. x1, x2, x3, y1, y2, y3. And you, for example, associate x1 and 2 value of the range. This is domain range again. For example, this and this. And suppose this and this. This is not totally irrelevant. In this case, is one-to-many. And one-to-many is a violation of the function. This is no function. Okay? No function. But the topic today is one-to-one. We focus in this part, in this. Because we want to study one new thing is called inverse function. Inverse function is the opposite direction. Suppose, I'm using another color. Suppose that I want to change the arrow, the direction of the arrow. And this is the inverse function. So in opposite direction is the inverse function. By the way, the notation that we are using this no, because it's no function. The notation that we are using to call inverse function is f, the same letter f, but -1. But this -1 is no exponent. So this is no equal reciprocal. No. This is a special notation que es inverse. Okay? This is the idea. Entonces, this is the inverse function. This is the inverse function. But the problem is that in one-to-one, the inverse function exists. This is another class. Okay, in one-to-one, in one-to-one, the inverse function, in one-to-one, the inverse function exists. Because in both directions, one-to-one, no? However, in many-to-one, is also a function, when you change the arrow of the direction, entonces es one-to-many, like that. Entonces this inverse function do not exist. Okay, entonces super important requirement. To get inverse function, the original function that we working in the example must be one-to-one. One-to-one. This is the first requirement. If it's not one-to-one, Professor, the inverse function that you asked me doesn't exist. It's not one-to-one. It's super important to verification first the one-to-one. No? Si it's not one-to-one, no. I cannot do anything but this one-to-one, entonces we start the work. Okay? How you determine, what is the easy way to determine if one function is one-to-one or not? Okay, guys, everyone follow me so far? Yes or no? Do you understand the idea one-to-one? And do you understand the idea? Well, okay. Maybe you say, well, professor, I don't understand very well the idea behind the inverse function. What is that? Well, this is common in the real life. I suppose that you understand very well. Suppose the function suppose the function, easy, suppose x plus 10. So the function is just linear function, is addition 10. Entonces, what is the inverse function? Well, the inverse function, I suppose que es x minus 10, it's opposite operation, inverse. And when you put together, when you are doing composition on those each other. So you are doing, for example, the composition remembers one function inside another function. Suppose que this expression, I plug in here. So we have no x anymore. We have x minus 10 plus 10. And this is cancelled. And the answer is x gets identity function. I'm making sense because suppose you have pick one number, 5. You add in 10, 15. And you 15 subtracting 10, 5. We come back again to the same case identity function. Okay, and there are many examples of the inverse function. Okay, you know in the real life. This was addition, subtraction, another multiplication, division, another is one multiplication, division. Let me see. Suppose g of x is equal to 5x multiplication by 5, and the inverse function is division by 5. It's x over 5. Okay. Composition this one. You plugging in this into this. G inverse composition G, no? In either order, or G composition, no, G composition. Es the first function, es the inverse function, G composition, G inverse. Es, you take that and substitution here. That's the 5 times x over 5. The 5 is cancelled, the answer is again identity function. So always, when you find, okay, I want to explain how. They say we are using now intuition, but I want to explain in detail the systematic way to find the inverse function for any function. Another possibility of the two inverse function is a square and a square root. You know, okay, so you put together on those each other, right? And there are many possibilities. But the most important is determine if the function is one-to-one or no. Okay, so what is the test to help me to understand if one function is one-to-one or no? Okay, is the horizontal line test. I suppose that you remember the vertical line test, but I want to recall it. Okay, recall vertical line test. The vertical line test is the test that we are using to verification see one one graph, one figure is or is not function. Suppose this function like that, and you apply a vertical line test. See if the vertical line cross the curve in 2 points, no function. See, cross always and only one, yes it is. For example, suppose this. Suppose this. When you apply the vertical, crossing only 1 point, it's a function. It is a function. This is vertical line test. Allow us determine if the graph corresponding with the function or not. But now focusing in horizontal. Horizontal is, suppose that we have that condition. Suppose that we have, for example, this function. And you apply the horizontal line test. Cross and only 1 point. Okay, so it's 1 to 1. So the horizontal line test allows us to determine if the curve is 1 to 1 or not. Suppose the parabola. Suppose the parabola like that. When you apply the horizontal line test, crossing 2 points, now the parabola is not the 1 to 1 function. Okay? Entonces yo say, bueno, professor, wait, pero entonces the parabola have no inverse function. Bueno, yes and no. Okay, actually, the original parabola, look at that. The original parabola, like that, is no 1 to 1 function. Therefore, we have no inverse. So the inverse function of this is the original function. It doesn't exist. However, this is under the supposition that the domain is all real number. Yeah, actually, you know it's all real number. However, see, I introduce artificially some restriction. Suppose que restriction restrict the domain, not only all real number, positive and negative. No, only the positive part, including 0. Why not? 0 to infinity, so the positive number. That part is the domain now. Es obvio que this function que es f of x equal x squared, the famous parabola, and here it's exactly the same, f of x equal x squared. Now it's a half of parabola, like that. Okay? Because I excluded the negative value. So when you apply the horizontal line test, you crossing only 1 point, therefore this is 1 to 1 now. Therefore, the inverse function of this function now exists. Okay, by the way, it's a square root x, you know. Because the square root and x squared undos each other when you connect it by the composition. No? Okay, suppose that you, for example, you format the composition. Let me do quickly. Is f composition f inverse is this inside this. Entonces it's like this expression go inside this, then it's like a square root x squared, something like that. And square root and x squared power is cancelled, and again we get the identity. A similar situation happens if you put in different order. Okay, for example, if you put in this order, okay, you put f is this, inside this, you have the square root x squared. Same situation. Okay? Entonces remember, the first thing that you should do in this problem is determine if the function gets given in the problem is 1 to 1. Okay? And always to form the composition, your verification, okay, your inverse is correct. Okay, one more thing, one more theoretical part before I start the exam. Okay. I explain again domain, range, F1 to 1, nice, I like that. Okay, X2, X3, Y1, Y2, Y3, okay, and you have a correspondence, a function. This is F. Yeah, you know also que in opposite direction is the inverse function. Okay, basically, the thing we are doing is interchange X and Y. Interchange X and Y. When you interchange X and Y, okay, this is the most important idea. You interchange X and Y, you form the inverse. And this is the formula that we are using to find the inverse function. Entonces, domain of F, que es the original function in that direction. Remember, domain is the first set. And this is the range of the F function. When you interchange, so this now is the domain of F inverse. And this is the range of F inverse. So this statement is super important. This and this. Okay, domain of the original is equal to the range of the inverse. Range of the original is equal to domain of the inverse. Okay? Okay, so now we are ready. We have every theoretical tools to understand the example. I bring two examples, but we are using this idea in throughout the chapter, no? Inversion function. Okay. Look. Example one. Example one. Let me make it zoom to see much better. Example one. Example one is a function, is given. It's given the function f of x is equal x cubic plus 3. Okay. We have 5 steps. Number one step is determine if the function is 1-to-1 or not. Well, professor, the only possibility you teach me is using the horizontal line test. Okay. I know that this is a QE function. I know the library of the function in Color algebra. The QE function look like that. Okay, this is a QE function. But this is a family of the QE function because we have vertical shift. So we have some translation, vertical shift, 3 units. So the transformation is in this case specifically, is vertical shift 3 units up, right? Up. Because now my new noise, my new function look like that. It's similar, the same shape, but you moving point by point 3 units up. Entonces that point que normally is 0,0 now is 0,3 because the y is increasing. This I suppose using my common sense and my imagination. Okay, this is the graph approximately, roughly, of course, of the function that's given in my problem. It is x cubed plus. And when you apply the horizontal line test, horizontal line, hypothetical horizontal line, and cross the curve in only one point. Now the super conclusion is yes. It is one-to-one function, professor. Therefore, the conclusion is the inversive function of this exists. Okay? This is my first step. Determine if it's one-to-one, because if the answer is no one-to-one, the inversive function do not exist, and we finish the problem. We cannot do anything. Now, the step number 2, is, in my opinion, the most important step is find the inversive. So far, we are doing using intuition, addition, subtraction, multiplication, division, square root. No. But I want to explain the systematic way inversive function equation. Find this for in general any function. Okay. I copy my function. My function is f of x equal x cubed plus 3. I replace f of x for y because they are equivalent, no? So I know in function notation, when you study function notation, y is equal to f of x. This is classical. In this case, most convenience using y. And this is now the important moment. Interchange x and y. Interchange x and y. In order to find the inverse. This is now no y anymore, it's x. This is no x anymore, this is y. Okay? So this is the inverse. What's the problem? It's an implicit. Implicit form. Implicit means the y is not isolated, but it's not clear, it's confusing. I need explicit when you isolate the y. It's easy. You're subtracting 3. You apply cubic root both sides. There's a cubic root of x minus 3 is equal to y. By the way, this is the new y, and this new y is the inverse. The super fantastic conclusion is the inverse function in this problem exists is equal to cubic root of x minus. And making sense or no? Or it's very, very weird. I suppose it can make sense because the original function, remember, the operation it's doing is cubing first and addition 3. And these are doing completely in opposite direction. It's subtracting 3 and find the cubic root. But just in case, to make sure that everything is perfect, I put the composition so that step 3 in the analysis of the inverse function is compute f composition f inverse. I suppose that the answer is identity and in opposite direction, inverse function composition of x. Not necessary to write here. Equal identity function. Because the action, the mathematical operation undoes each other. Okay, let's do it in this order. And this order is f inverse the first function is this. Complete inside the f is this. How you are doing this? Well, you replace instead of x here, you copy. Cubic root x minus 3 cubic. So you replace x here by the entire inverse plus 3. Let's see what's going on. One of these is cancelled. Cubic root and cubic is cancelled. Stay only x minus 3 plus 3. And 3 plus 3 is cancelled, and we get identity made exactly we expect. This is a confirmation, guys. We are doing well here. Likewise, let's do it in opposite direction. In opposite direction is different. Is you plug it in x cubic plus 3 inside this. Entonces, like a cubic root No x anymore. No. It's x cubic plus 3 minus 3. That you replace this expression here inside the x. And similar situation happen. We have these 3 is cancelled. And we have cubic root of x power 3. It's just x gets identical. And this is the confirmation that we are doing well. So this step 3 is a confirmation. It's a confirmation of the that we are doing well. Remember, we have 5 steps in this analysis of the inverse function. Number 4 is determine domain and range. So we need to determine 2 domain of the original. Okay, the original is f of x equal x cubed plus 3. And range, why not? Of the same function, f of x equal x cubed plus 3. And also domain of the inverse function. If the inverse function was cubic root x minus 3, no? And the range of the inverse function is the same expression. Well, es obvio que the domain, looking the graph, or not looking the graph. I know the agreement to find the domain of the any function is, I suppose, that the domain is all real number except restriction. And we have restriction only when you have division, when you have a square root, not cubic root, a square root in the top or a square root in the bottom. And the restriction is q not 0, expression e no negative, and here expression e must be positive. Okay, so this is the potential restriction, and they are combination, of course. But in this case, we have no restriction, no? Because we have no division, we have no square root. In this case, we have cubic root. The cubic root have no restriction. So basically, when the index of the root is odd number, no restriction. Only when there's even, maybe square root or 4 root, maybe, right? But in this case, no. Therefore, the domain here is all real number. And this is exactly the same. Domain of the original is equal the range of the inverse. I just copy and paste here because it's the same. And domain of this, well, okay, we have no restriction. The same idea. When it's cubic root, no. Why no, guys? Let me explain in detail. Look, you need to remember, you have to remember, for example, the graph of the function square root and the function cubic root. A square root look like that. We have no negative part. That is the reason that the domain of this is bracket 0, infinity. However, cubic root no. Cubic root look like that in both directions. Therefore, the domain is all real number. And it's classical because, for example, look, the square root negative number, negative 4, is imaginary to I. This is totally out the domain because the supposition of the function is that the domain is all real number, no? However, cubic root negative 27 is negative 3 because negative 3 times negative 3 times negative 3, 3 times is negative 27. It's exactly the number that we need inside the radical. So now the conclusion is easy. The square root of the negative number is imaginary, totally out the domain. However, cubic root of the negative number is real. Therefore, The domain again here is already a number. It's a coincidence, not always happen. And the range for the original is exactly the same, the domain of the inverse. So everything is already a number in this specific example. Finally, the 5th step is the relationship that exists between the graph of the inverse function and the direct function. Let me try to do by hand, and after we are using decimal. But I want to erase the board now. I can? I can erase or no? Yes or no? Let me know.
Yes.
Okay, look at that, look at that. Let me try to do the graph by hand. And after we are using decimal to see elegant way. Okay, look, make it zoom. Okay, I want to do the graph. Of the first function que es x cubed plus 3. Suppose 0, suppose 1, suppose -1. 3 points is enough. And 0, the answer is 3. 1, 2, and 3 here. This point is 0, 3. It's a point belong to this function because when the x is 0, the y value is 3. No? And 1 cubed is 1 plus 3 is 4. So 1,4. Here 1,4. And in -1 cubed is -1 because when the exponent is odd, it's -1, just positive. Positive 2 is -1, 2. Therefore, my graph look like that. So the shape is the shape approximately to the cubic function, but is no surprise, is moving vertical shift, no? 3 units up. Super. How you are doing the graph of the inverse function? The inverse function is cubic root x minus 3. Well, we can do using the graphic of the cubic function, but no. We're doing it in a different way. Remember the idea that connecting this function is interchange x and y. Therefore, you are doing this action point by point. For example, that point is x equal 1, y equal 4. And the inverse would be 4,1. So interchange x and y. So it's 2, 3, 4, 1. 1 here. This point is 4,1. Do you see the idea? This point and the original is corresponded perfectly with the 4,1 and the inverse. And 0,3 is 3,0 here, 3,0. This point is 3,0. This point is 3,0. And this point is -1,2 is 2, -1. Entonces 2 and -1, I suppose que here, this point is the point 2, -1. Okay, now when you connecting this point, our graph look like something like that. Okay, and make sense because I know the graph of the cubic function, when we study the library of the function, equation, and graph of the cubic function, look like that, no? It's a cubic function. Y equal cubic root x. But we have some transformation. Look, -3. -3 is like that. Look, the function x minus 3 represents horizontal shift 3 units to the right because it's minus. So make it sense, perfect. Look, it's something like that. 1, 2, 3. So matching perfectly with idea. Okay? But in my opinion, it's easier doing in that way. Interchange x and y. This idea. Interchange x and y. because I have the graph in blue color of the original, and you find in the green color the inverse graph. Interchange X and Y. Notice that this graph is symmetric to the line. This line beset first quadrant and third quadrant. That's the line Y equals X. Okay, by the way, this is the identity. That's perfect symmetry. So this distance is exactly this distance. This distance is exactly this distance. Oh, see, we are doing well, no? This is like an image. This is behave like a one mirror, symmetric. We respect the line Y equals X. Let's do it more clear in decimals. I prepare one decimal for you to see more clear. Okay. Let me switch into decimals. Decimals now. Good. Okay. I suppose you see this one, right? Look, this is my function. X cubed plus 3. This is the identity. And this is the cubic root. I put it like that. In this one, we have, well, but it's weird. Much better using a fraction exponent. 1/3 is equivalent to, say, cubic root, no? And look at that. Boom. Let me make it soon to see. And I don't know, I put black color, everything. Black color is the original. Let me change the color here. Maybe green. Maybe green. Maybe green color. Okay. So this is the original. This is the inverse. This is the famous point K-Salane, 0,3, 1,4, negative 1,2. This is the corresponding point. Now you see it's perfect symmetric. Now clear. And this is the line, is the no asymptote, but it's a symmetric line, okay? It indicates us the relationship between any function and its inverse. Okay, I put in like a, you know, the style I put dotted line in black color. Any question, guys, in this first example? It's easy, it's understandable, it's complicated. I bring another easy example, and let's move on to another topic. Okay, switch into whiteboard. Whiteboard. Oh. This is I did well, no? Switching whiteboard, yeah. Do you see whiteboard? Okay, let's move on to example 2. Example 2. Example 2 is, look, example 2. Example 2 is easy, but bring me a new situation. Suppose f of x is equal to x squared, semicolon, x greater than or equal to 0. When this situation happens, when you see this in the book, or when you see this in the lab online, you don't understand very well what is that. Professor, what the hell is that? Well, this is a restriction. This indicates us that this domain. That there are some restriction domain of F. Why is important? Because remember the first step is determines if one-to-one or no. And the test that we're using to determine is horizontal, ¿no? Horizontal line test. Entonces en this case es parábola, pero actually it's a half of the parabola, no entire parabola. Only valid for the positive part, include 0. Touch here, 0. No the completely parabola. Si es completely parabola, so suppose que I delete this restriction. Entonces the supposition without this restriction is an all real number. And the all real number is the entire parabola. And when it's the entire parabola, when you apply the horizontal line test, fail the test, but in this case, no, because using this restriction, this become this function, que actually the function is x squared semicolon, and this specific domain, now this function using this restriction is 1 to 1. Therefore, the inverse function exists. Okay? Now we prove that the inverse function exists. Okay? Number 2 is the most important moment, que is find the inverse. And the inverse, I can use in the intuition, que is square root, no? But okay, I don't know. I copy f of x equal x squared. I copy y is equal x squared. Interchange x and y. Important moment. X is equal y squared. Now apply square root both sides. So say square root x equal y. And this is a new y. And this is inverse x. Exactly we predict. Because there's no surprise for us. The square root is inverse function of the square power. No surprise. No surprise. This is very clear. And what about domain and range? It's obvious. It's obvious that the domain of the function x squared, the range of the function x squared, the domain of the function square root x, and the range of the function square root x. It's obvious that the domain of the square root x is from 0 to infinity. And this is exactly the same, the range. Well, okay. And the domain of this is given. Remember, it was x greater than or equal to 0. Okay, in function notation is 0 from infinity, and this is exactly the same. In this case, a coincidence. It's the same. But you can see that according to the restriction of the domain, is the reason that the function is 1 to 1. Now, still 1 to 1. Therefore, the function is invertible. Why not? Okay. Number 4 is the confirmation. You are doing composition, F composition, F inverse. Should be identity, or inverse function composition F should be identity. No? The inverse function is square root, and the square root inside the square is equivalent to say x square root x squared. Okay, wait, let me copy. Inverse function is a square root. The original function is x squared. You put this function inside. And now in opposite direction, you put a function like that, square root x squared. Again, confirmation. Work perfect. And the graph, let's do it now by hand now. Let's do it in Desmos. Switch into Desmos. To see this idea. Well, need to open Desmos now. Switching. Okay, do you see, right? Desmos. Now that was example 1. I want to see example 2 now. Example 2 is, look at that. In Desmos, the restriction and specification using the curly bracket is x greater than or equal to 0. And the graph look like that. Look, the blue is the graph of the square, and the orange is the graph of the square root. And you see the perfect symmetry with respect the line y equals. Wow. For example, that point gets 2,4 because 2 squared 4, and the square root should be 4,2 because the square root 4 is 2, no? And 1 is a coincidence because 1 square is 1, and square root 1 is 1. And 0 is trivial example. Any question? No? It's clear. It's clear. It's clear. It's clear. Okay. Okay, perfect. Jose. Okay, Jose. Okay, let's move on to another topic. Important, but extremely important topic, que is a new function that we studied in this chapter. So in this chapter, we working with the special. It's like a, transcendental function. So no more polynomial, no more rational function. No. It's a transcendental. Basic is, the name is exponential. Exponential function. Okay. It's a family. Therefore, it's exponential function in plural. Okay. Let's move on to definition first. Definition. Definition is a function like that is equal a to the x power. Who is a? Well, a is the base. Is the base. Is the base. And the base is real number, but not all real number. Real number. But we have restriction such that a is always positive number, illegal to be negative. In mathematical language, a is greater than 0, positive number, right? But one more restriction, a is never 0 and never is 1. Why no? Because it's trivial. So because if the base is 0, 0 to the any number is 0, and 1 to the any number is 1. So this is stupid. This is trivial. Trivial case. No important. Entonces, basically, we have two possibilities. If a is greater than 1, let me try to do the whole real number to understand this. Infinity positive, infinity negative. This is 0. This is 1. At the base, we are talking about the base. The base is greater than 1. The base is in this direction. No 1. No 1. 1 because it's trivial, no? So in this case, the exponential function is increasing. We study in detail, I promise, the graph of the exponential. 1 increasing, like that. Normally, when it's increasing, another name that we are using in the book is growth. Exponential growth, because it's increasing. If a is in between 0 and 1, remember another possibility of the base is in between 0 and 1, but not include 1 and include 0. We're talking about 1/2, 1/3, 1/4, 1/5, okay, number less than 1. In this case is decreasing, exponential, decreasing function, decreasing exponential. And normally the name that we use in the book to call when it's decreasing is decay. Exponential decay. Typical exponential growth, increase. Exponential decay, decrease. Okay. Entonces I want to I want to explain something important. Look, this professor, this look like it's similar. No, it's not similar. It's not totally new. You never seen before in your life. No, maybe here so far in college, no. Okay, suppose 2. 2 is possible. The base 2 is possible. 2 to the x power versus x to the second power, that you very well know, is a power function, it's a parabola. And this is a new one that we study, exponential. In this case, exponential growth, something like that, exponential growth. But okay, the thing I try to explain is, you compare how fast increasing this function and this function. Who wins? Who go fast? What increasing faster? Okay, suppose compare with the x cubed, or to the x to the 4, or to the x to the 10,000. Okay, this function increasing when the exponent is bigger, increasing faster. However, exponential win. Exponential increasing super fast than this function, the power function. To illustrate this idea, I propose you one puzzle. Okay, the student get the answer for this problem. It's a puzzle. Get 10 points extra in the test work. Okay, puzzle equal 10 points extra in test 4. Pay attention. And we have only one opportunity to answer the question. So you fail, I put your name here. So you type in using the chat, no? I see your name. Suppose the answer is 20. This is wrong. I put wrong. You put your name, Maria. Maria failed. And Maria have no more opportunity. So you cannot guess it 20, 30, 45. No. Okay? Okay, what's the idea? The idea is about coronavirus. The propagation for the coronavirus. This is the one coronavirus. Let me try to do my best. Coronavirus. And coronavirus contaminated one student in Miami-Dade College. One other college, one other institution. Doesn't matter the name of the institution. And the propagation for the coronavirus is, for example, in the real life is more fast than this. But to simplify the thing, I suppose that this student contaminate 2 students. Actually, I suppose that the rate of increase is not 2, is 3, 4, or 5. So this situation happened now. Now is T0. And T equal to 1 day, one day, we have 2. At T equal 2 days, how many students you believe they contaminate? How many? You are here or not? Do you hear me or not?
We're here.
How many students is contaminated today? Is infected in today?
The whole what?
Again. I don't see the board. Oh, sorry.
We on.
Sorry. I believe that you know that. No, I start story again. Okay. Don't worry. Let me try to do. Now you see the whiteboard or no? No? Okay.
Not yet. No. Still this one.
Don't worry. Sometimes I need to restart. Selection again. Okay. Now minimize. Now you see, right?
Yeah, we see it now.
Yes.
Oh.
Perfect. Yes. So I talk about one puzzle. So you discover what's the answer of this. You have 5 extra points in the test 4, no? So we have, for example, here coronavirus. And coronavirus contaminate 1 student in Miami-Dade College. Miami-Dade College. This is now, today. 1 day after that, we have 2 students contaminated. I suppose it is the rate of change, duplication, no? And the second day, 4 students, no, is contaminated because this student contaminated 2 more, and so on. How many students is contaminated in 3 days? In your opinion?
7.
7, no.
6. 6.
No. 6, no. 6, no. Okay.
8. 8
Yes,
Hey.
Jose. Hey. Okay, this contaminate 2, contaminate 2, contaminate 2, contaminate 2. 1, 2, 3, 4, 5, 6, 7, and 8. And how many students contaminate in 4 days? 8 noise. Putting off the microphone.
12.
In 4 days, how many students? 16. Very well, Jose. Now you understand the population of the students seek duplicate anytime, no? Duplicate. So duplicate, for example, in 5 days 32, in 6 days 64, and so on. Duplicate. O sea, es 0, no es 1, sorry, es 2, es 4, es 8, es 16, no? It's a sequence.
Wait, Professor, so we have to find the pattern first in order to
let me finish. Yeah, the pattern is clear. The pattern is 2 to the x power. Exponential function. Look, the pattern is 2 to the x power. Suppose you evaluate in 0, 2 to the 0 is 1. Suppose 2 to the 1 is 2. Suppose 2 to the second is 4. This is a pattern. This is formula. Yes or no? Yes or no? Okay. Now, pay attention. Don't interrupt me. Okay. And we continue following the same pattern, 2 to the x power. Suppose que in 1 month, this continue, in 1 month. Okay. Okay. The authority in Miami-Dade College don't like the whole college is contaminated. No? Therefore, according to this part, the whole college. This is Miami-Dade College. Miami-Dade College. See you don't apply the vaccine right now. In 1 month, the Miami-Dade College is completely 100% infected. But the crucial moment in which 50% of the Miami-Dade College is contaminated, and the other no is health, okay, is the crucial moment in which you apply the vaccine, and I save all students. But I want to determine exactly how many days we have this condition. How many days at most or at least I need to wait into this moment get 50%. 50% the population for the Miami-Dade College is infected. Okay. Do you understand the question or I repeat the idea? Okay, according to the process, this is totally hypothetical. It's a mathematical, pero I put a phone using Miami-Dade on a virus. But this is classical. You hear, I suppose, in this pandemic, que the propagation is exponential. Okay, this is the idea. Pues exponential. You don't understand very well exponential function. The people don't understand because it's beyond to the common sense. Okay, entonces I suppose following that partner, Miami-Dade or one country, suppose one country or whatever is 100% infected, but I need to find the 50%, it's a half of the population. So now open the answer, guys, using the chat and answer me how many days the population, the half of the population is infected. Okay, come on, thinking. But this is for today. No, you have no time to computation, use a calculator. No, use intuition. Use intuition first, And also after I want to explain mathematical, what is the solution for that problem. Okay? Okay. You have idea or you are totally lost. You understand the problem or you don't understand. This is the issue. The most important is you understand the problem or you don't understand.
I don't understand it.
You don't understand. Okay. Okay. I repeat in few an elementary word. You be the propagation for this virus. Okay, suppose que the population, so the number of the students sick is duplicate any day. Yes or no? Chance?
Yes, sir.
Okay. I told you. Okay. Jose get the answer. Oh, Jose get the answer. Jose, the answer is 29 days. Jose get the answer. Chance, let me finish my explanation for you. Now, I suppose I tried to confuse a little bit, no? 1 month represents 30 days. And 30 days, it's a fact that the entire Miami-Dade College, 100% is sick. And my question was, at what day is a 50%? 50% is a half of this. So the partner is 2 to the x, and 2 to the 30 is equal to the total population for this college, this country. I don't know. This is completely illogical, but and divided by 2 get 50%. And 2 is 1. You subtract in the exponent, it's 30 minus 1 is 29. And 29 is the solution for this. Okay. At 29, make it sense because at 29, we have 50% of the population sick. And 30 is 1 day after, we have 100%. Okay? Entonces, Jose, remind me, 10 points for you extra in the test 4. Now, 5 points extra. No, Jose is excluded. Another student, 5 points extra. What happened? What happened? Explain me what happened at t equal 31 days. What happened in 31 days? So 1 day after the 100%. What happened? Try to explain me using your own word. What's going on? How many students sick? Because the vaccine never coming. Entonces increasing the student infected with the coronavirus. Entonces, no idea. What happened with the population for the student infected? Come on, opinion. 5 extra points. No sé. Another student. Come on, guys. What's going on? Exponential function. Okay. Yes, Zaira. Henry, you understand or you don't understand? Totally lost?
I lost. That's why.
Yeah,
That's
I
why.
know.
Mm.
But this is understandable because exponential function. That is the reason I put this example.
I
Exponential
understand
function.
the I understand the exponential function, but I don't have I don't get the.
Okay. I understand very well. Don't worry. I understand very well. This is like an application. Entonces, in the application, this is weird because it's beyond our imagination. We suppose always que the function increasing like a linear. It's clear in my mind, our mind is linear, no? Duplicate. No, but it's not linear. No, it's exponential. That is the reason that the pandemic increasing too fast. Okay, so you have no idea what happened in 31 days? No, nobody. 1, 2, 3, nobody. Okay, entonces in 31 days we have 200% because any day or any period duplicate the population. See, in 30 we have 100%, and in 31 days we have 200%, and 200 represent 2 colleges. or 2 countries. In 32 days, we have 400%. And 400% represent 4 colleges. Okay? And so on. A college, 16 college. Okay, entonces exponential, the thing I try to convey is the exponential function increasing too fast than, and I suppose que the base is 2. I suppose que the base is 3, or say 4. So I suppose que one infect contaminate 6 people. Okay, the increasing of the exponential is too fast. Okay. 10 points for Jose. No 5 points for anyone. Do you understand or you don't understand? Any more clear now? More clear or not clear?
Not really, but I will get it.
Okay, don't worry. I want to explain in detail now exponential function. I'm using the base 2 because in my opinion, it's easy to understand. Now, we focus in detail to study exponential function, no application. No application is after. Yeah, the week after the holiday is the application. Then, supposed to do this, to analyze this function, I propose you do the graph. And to do the graph, I propose do a table like that. I put x here. I put y equal to the x. I put the point x comma y. Suppose 0. Okay, y is equal to the 0. Yeah, I know that any number raised to the 0 power is 1. Therefore, the point is the point 0, comma 1. Oh, this point is the universal point, because this point 0, comma 1 is for any exponential, regardless the base. Because si es 3, 3 to the 0, 1, is 4, 4 to the 0, 1. Any number raised to the 0 power is 1. The point 0, comma 1 is universal point independent of the base. Suppose 1. 1 is y equal to the 1 power. And the point is 1 comma. Suppose 2. Y is equal to a square. 2 square is 4. The point is 2 comma. And so on. It's exactly the puzzle. The population is duplicate. And 0 day is 1, and 1 day is 2, and 2 days is 4, and 3 days is 8. But in this case, I want to study not always positive numbers, negative numbers. Suppose negative 1. Negative 1 is y is equal to the negative 1. And negative 1 is reciprocal, it's 1/2. And negative 1, comma 1/2 is the y value. And negative 2 is similar, y equal to the minus 2 is 1 over 2 squared, and 2 squared is 4, 1/4. So negative 2, comma 1. Okay. So we are ready to do the graph of this. Actually, do you understand this or no? Do you understand 0 exponent is 1? Do you understand que negative exponent is reciprocal? Ernest, you follow me?
Yeah, I understand.
Yeah, I know. Don't worry, I understand very well. So this is just, a funny introduction that I create always in my lecture to explain que the exponential function increasing too fast. Pero no necessarily this is you need to use maybe too much imagination, no? Okay. Look, let me switch into decimals. Okay, but not here. Exponential. Okay, look at that. There you go. Exponential function. Okay, look at that. Exponential function. This is the graph of the exponential. Let me put in more projector mode to see much better. Okay, exponential function is. Okay, look at that. Look, 0 is 0,1. 1 is 1,2. 2 is 2,4. And so 3 is 3,8. You see how fast increasing the exponential function. But however, in the negative part, they're using blue color point, is negative 1, 0.5 is 1/2, negative 2, 0.25 is 1/4, negative 3 is negative 3, 1/8, and negative 4 is 1/16. You see how when you put a negative exponent, the value for the y decreasing. This is small, and approaching to 0. No, never touch, because it's asymptotical. So we have in this function we have a horizontal asymptote at y equals 0. Look, this is the graph of the exponential. Do you see? Do you understand or no? Yes or no?
Yes, sir.
Okay. If you understand, yes. Okay. Do you understand now? We are ready to write in the whiteboard the most important property of the exponential property of the exponential. Okay. Do you see the whiteboard? No, not yet. Let me see.
See, we see it.
You see? Okay. Super. Okay, super. Okay. So I write here a property of exponential. Okay, the first property is number 1, domain. Domain is all real number because we have no restriction. Look, my function is f of x equal 2 to the x. We plug in here any number, positive, negative, 0, no restriction, no, never we have error because we have no division by 0, we have no square root, no. The domain is all real. However, the range, no. The range you see is only positive answer because the curve look like that. And we have asymptote here, horizontal. So we never have exponential function in the negative part here. No. So the range is from 0, not including 0 because this asymptotically approach, but never touch, never cross, comma, infinite. This is the range. It's obvious in this case it's increasing. You see it's increasing because when you move from left to right, the roller coaster car goes up. So you travel on the curve, this is increasing, no? Remember, the motion is from left to right. Increasing function. It's increasing. And it's neither, we have no symmetry. And neither. No even nor odd function. Number 5 is horizontal. We have horizontal asymptote, always at y equals 0. Yes, this. And the test number 1, guy, and the test number 4, sorry. The first question is do the graph of the one exponential function. And number 6, in my opinion, is the most important property. It's the typical points that allow us to do the graph of any exponential. And this is the universal point, is 0,1. Another is 1,2, 1,2 because the base is 2 in this example. But in general, si the base is no 2, es 3, es 4, es 5, es 1,8 in general. And negative 1, reciprocal. 1/2 in our specific example, but in general es negative 1,1/8. Entonces, suppose que in the test, I ask you, do the graph of this exponential function. Y equal 4 to the x. It's easy. I understand very well. Because I know que es increasing. I know that we have the famous 3 typical points, this, and this. In our specific, the base is 4. So we have 0, 1, and negative 1. And 0 is 1, I know, because this is the famous point 0,1, universal point. But in 1 is 4, because the base is 4. So it's 2, 3, 4. Okay? This point is a point, 1,4 in the base. When the 1 is exponent, it's 4. And when it's negative 1, it's 1/4. Because the y is equal 4 to the negative 1 is 1/4. So 1/4, I suppose, is 1/2, half of the half, 1/4 here. And the point is negative 1, 1/4. Okay. And also I know that this curve contain one horizontal asymptote here at y0. Therefore, my exponential in the test look like that. Any question? Okay. And this is the complete the picture. No. We need to see another example. Okay. Okay. Basically, 3 points is enough to plot the exponential. So you want more, you want more. Suppose that you select 2 and negative 2. Okay. It's 2 positive. So says y is equal 4 to the second power gets 16. And the point is here. And si es negative 2, y is equal 4 to the minus 2. It's 1/16. And you divide this by 1/2. 1/4 is too small here. And negative 2, no? Yeah. Negative. Okay? Did you see or no? No?
Yes, sir.
Okay. Little by little, this is a process, Ernest. You know my way. Little by little, you understand. Okay, I want to complicate a little bit now. Suppose that I have another exponential. Ooh, like that. Look at that. F of x. Example 2 now of the exponential. Suppose f of x equal 1/2 raised to the x power. Whoosh. You remember, I explained one moment, if the base is bigger than 1, is exponential growth. Because the function is like that, increase. However, if the base is in between 0 and 1, a fraction, is exponential decay. I have no idea how it look like. I have no idea. So decay means decreasing, no? Decrease. Okay. Let me analyze it a different way. I'm using the table again. However, another possibility is using my knowledge of the transformation. I know that 1/2 is equal to the minus 1 to the x. So I transform my 1/2 into 2 raised to negative 1, no? It's reciprocal. And you multiply the exponent of 2 to the minus. And compare this exponential and this exponential. When this is positive, it's this. But when this is negative, is you remember transformation when you have a function and you replace x for negative x. That's reflection, no? Do you remember reflection? reflection. When you replace x for negative x, es reflection. Reflection about the y-axis. Si es reflection, entonces es because the new exponential look like that. Okay. I have some idea using transformation, but I want to explain in detail again. Look, I take advantage to do again the chart, the table. X, y equal 1/2 raised to the x power, and the point x comma y to plot the point. And again, we start 0. Y is equal 1/2 raised to the 0 power. It's over the 1. Because I don't care the base. When you raise to the 0 power any number, the answer is 1. And it's the confirmation that it's a universal point, 0, 1. Suppose 1 is 1/2 raised to the 1 power. It's over the 1/2. The point is 1, 1. Suppose 2. Y is equal 1/2 raised to the 2nd power, and 1/4, 1/4, 2, 1. Nice. So far, it's clear. Everyone understand very well. Now, let's see negative number. Entonces negative number, when it's exponent, es reciprocal. Entonces y is equal 1/2 raised to the negative 1 is 2. Because you flip the number. The number is negative 1, 2. And negative 2 is y is equal 1/2 raised to the negative 2 power is 4. Because you flip it and square. The 1/2, when you flip it, is 2 over 1, it's just 2. And when you raise to the 2nd power, is 4. And the point is negative 2, 4. Okay? Entonces es similar, but it's, look, the behavior, this is exponential growth, classical, 2 to the x or 3 to the x. And the exponential decay is something like that. Symmetric will respect the y. Totally symmetric. 1 point here is image, 1 point here. But this is decay because analyze from left to right, the roller coaster car is going down. Remember here, the roller coaster car is going up. This is increasing function. This is decreasing. Okay? Let me see in this more clear, more detail, more detail. Switching to decimals. Okay. Okay. I suppose you see decimals. Well, this is the last example. Example 1. Example 2 now is different. It's like that. Boom. Look at that. Exponential decay when the base is less than 1. 1/2 raised to the x power. Entonces we have the universal point, 0,1. And don't forget the typical point, que es 1 and negative 1. For example, in 1 is 0.5 because the base is 0.5. And in negative 1, the answer is 2 because it's reciprocal. Likewise, and 2 is 0.25, and 3 is 0.125, and negative 2 is 4, and so on. And, okay. It is exponential decay, it's decrease. Do you see? Do you see?
Yes, sir.
Little by little you understand. Okay, guys. Let me switch again to the whiteboard. And the rest of the time that we have, I need to explain new things. Look. Whiteboard again. Boom. Erase everything. Erase everything. Good. Now the topic that we're discussing now is exponential equation. Exponential equation. Oof. Exponential equation. Exponential equation. Okay, let me explain in detail exponential equation because we have time. Suppose this elementary kindergarten example. 2 to the x equal 4. Be careful, because it's not 2x equal 4. And this is the equation that we're doing intermediate algebra. You divide it by 2 both sides, no? X equal to. In this case, no, because this small x represents exponent, no? This is a linear equation, linear. This is not linear, this is exponential. Because the unknown is located in the exponent. And so how you solve this? Well, there are many ways to do that. However, the easy way, in my opinion, is considering that you try to express it both sides of the equation using a common base. So 2 stay like that. But I know that 4 is 2 to the second power. So if in that moment we have 2 exponentials and the base is the same as 2, it's because x is 2, the exponent should be the same or must be the same. Now you manipulate both sides. This is super elementary example. I want to complicate more this, of course. You manipulate both sides in order to try to express it using the common base. Sometimes it's possible, sometimes no. When it's no, we discussing no today. Today we practice the relatively easy exponential equation. And when you express it both sides using common base, magically, my equation is no exponential equation anymore. You take the exponent equal the other exponent, and that's it. Final answer. You cancel out that too, but I don't like to see this because it's not strictly nice to talk about cancel out. Okay. Let's see example. This is the introduction example. Example 0. Example 0 is very, very straightforward. Let me try example 1. Example 1 is 2, 3 minus x equal 8. So for x, 3 minus x. Okay, let me erase this to see better. This is exponent. This is 3 minus. This is typical. We using what is the common base in your opinion? What is the common base that allow us to solve this exponential equation? What is the common base? What is the common base? You need to manipulate both sides in order to express it using the common base. What is the common base in this case? Help me. Help me, please. Come on. No idea. What's going on today, guys? Come on, Jose, help me. Natalie, help me. Erne, help me. No idea. Wow. Okay, you know the fact that A is 2 to the third power, no? 2 times 2 times 2. 3 times is 8, no? So you copy 2 to the 3 minus x is equal to the cubic. In that moment, we have 2 exponential function and the base is the same. Therefore, the exponent is the same. You copy 3 minus x equal 3. This exponent is equal to this exponent. When you solve for x, it's solve because 0. Okay, the answer is 0. Do you understand or no? Let me know, guys. Yes, no. Come on.
I understand. I understand.
Okay, okay. This is no big deal. Suppose the second example, get 5. Okay, okay. Makes sense, right? Jose. 5 raised to the 2x plus 1. I want to complicate a little bit. And the test, you have two equations similar to this. A little bit more complicated. 25, 25, 25. My question is, they are a common base. Help me to solving this problem. What is the common base in this case? And between 5 and 25. 5, very well, because 25 is 5 squared. So you're right, this stays the same, but this no, I change 5 squared. Now, if we have two exponential functions and the base is the same, it's because the exponent is the same. So you write magically, this is magic, mathematical magic. You ignore the base, you take only the exponent equal each other, and you
One
convert.
over two.
Exactly, you convert this horrible exponential equation in one nice linear equation, and the rest is pretty easy. 2x is equal to minus 1 que es 1 divided by 2 is 1 half. The answer is 1 half. Everyone follow me?
Yes, sir.
Everyone follow? Yes, bueno, bueno. Okay, entonces you help me now. Example 3, exponential equation, 27 raised to the 4x. This is exponent, guys. This is small indicate exponent equal 9x plus 2. This is exponent. My question is, what is the common base?
You ask Jose or everybody?
Say again?
Jose or everybody?
No, everybody.
Uh,
You
this
want
one is 9. 3. 3 to
9.
5.
Es 3. Natalie Navarro say que es 3.
Not
Es 3, es 3. Es
yeah.
3. Why? N, why is 3? Look, because 27. No, 9 no. 9 no. 9 no. Okay, 27 is 3 to the third power. And 9 is 3 to the second power. Very well. Okay, 9 no, because 27 is 3 times 9. You try to express it. And 9 is 9. Okay, common, pero we have extra 3 que I cannot solve. Not good. This is a much better option. So you replace, not 27 anymore. No. It's 3 to the third power. Raised to the 4x. Equal. 9 is 3 to the second power. Raised to the x plus 2. Important property of the exponent. When you have, for example, x to the second to the third, is equal to x to the 6 because you multiply the exponent. In this case, also you multiply 3 to the 12x because 3 times 4 is 12 equal 3 to the 2 times this expression que es x plus 2. Es obvio que es mandatory to put the parenthesis because these two multiply the whole thing. Entonces you have in this moment two exponential functions, the same base que 3, nice. Therefore, the exponent is the same, 12x equal to parenthesis x plus 2. When you solve this elementary intermediate algebra equation, apply this 3
Plus 4.
Go ahead.
2x plus 4.
I
Yeah.
try to solve for x. Subtract 2x equal 4. Combine like term. Este, no?
Yeah.
Noise divided by 10 both sides. X is equal to 4 over 10. Okay, when you reduce in lower term, x to 5. Divided by 2, 5.
2, 5.
The answer is 2 over 5. Excellent. The answer is 2 over 5. Very well. This is exponential equation. I promise the next class we study more complicated exponential. Example 4. example 4 is parenthesis radical 3 raised to the x plus 4 is equal 3 to x. Okay, I introduce radical. Okay, my question is, what is the common base? My question is, what is the common base?
3.
3 is the common base. Very well. 3 is the common base. Because I can express radical 3 like a 3 to the 1/2. Remember conversion, radical notation to fraction exponent. And 3 is 3 to the 1 power. And so you replace, this is 3, 1/2 raised to the x plus 4 is equal to 3. Multiplication of the exponent is 3 to the 1/2 times x plus 4 equal 3 to the x. If we have two exponential functions and the base is the same, then the exponent is the same. And magically, we convert exponential equation to linear equation. Okay? Yeah, you apply the algebra that you studying in intermediate algebra. And I suppose that you want to get rid of the fraction, multiplication by 2, the entire equation by 2. So it's x plus 4 without this, because 2 here is 1 equal to x. 2 times x is 2x. And now u 4 is equal to x minus x. Move this x to the right. Combine the term. It's x equal. Okay, we have time to suppose 2 more. And that's it. Very intensive day. Like this course is very intensive. You know, I'm teaching in 16 weeks this subject in the afternoon, and we are doing exactly the same of this. So I explain slow down in 16, but in 8 weeks, exponential course, too fast. Suppose example 5. Example 5 is 2 raised to the 1 minus 2x equal 8x plus 1. Huh? My question again is, what is the common base? Equals. What is the common base? 2 again. Natalie say 2. Because 2 is 2. And 8 is 2 to the third. Super. The 2 stays the same. 1 minus 2x is equal to 2 to the third power raised to the x. Now multiplication, the exponent. When you have different level of the exponent, you multiply. So 2, 3 times exponent. If we have two exponential functions and the base is the same because I create artificially common base 2, the conclusion then the exponent is the same. 1 minus 2x is equal to 3 times x plus 1. Wow, it's amazing. Okay, I destroy the exponential equation. I convert to the linear equation. And the rest is super easy. Apply distributive property. 1 minus 2x is equal to 3x plus 3. Well, let me try to solve for x. I propose this one stay here, minus 3, I move to the left, the x stay, plus 2x, I move to the right. This is negative 2, and this is 5. Divided by 5 both sides, the answer is x equal minus 2 over 5. That's the solution for this exponential equation. One more, the last one. I promise get the last one, number 6, and that's it. The last one. This is easy. We are solving in 1 second. No, 1 second, no, in 5 seconds. Okay, suppose the example number 6. This is 2/3 fraction raised to the x power is equal 9 over 4. Entonces, what is the common base? Well, in this case, a fraction. Entonces, I need to find two common base, not only one. Okay, for example, for, I don't know, common base, maybe. But I know que 9 is 3 to the second. So I try to stay relationship between left hand side and right hand side. Go ahead. And
flip it over. It's gonna be
flip it over. Very well. Flip it over. I like that. And 4 is 2 to the second power. Okay, Ernie, let me try to do it that way. Look, 2/3 raised to the x power. And 9 is 3 square and 4 is 2 square, no? And you can write, if you want like that, 3 over 2 square. It's the same, right? And you are doing exactly the same. You say now, flip it over. You flip it over. Which one? The left-hand side or the right-hand side? What do you want?
the right one.
The right one. Okay. So 2/3 stay the same. And I flip it over this 2/3 again. But I put -2, no? Remember, negative exponent is reciprocal. Now, in this moment, if we have two exponential and the base is the same, que es 2/3, the common base is 2/3. It's because x is equal -2. End the story. Guys, I wish you happy Thanksgiving. Okay? No mathematics, please. Take a break. Once you have some pain, remember today I want everyone send me the test on paper and submit the test online. Any question that you have, any question that you are stuck, I can help. Okay? I can help. You email me, take a picture exactly the question. Remember that your problem that you see in your platform is not exactly the same in my platform, and another student is different. And this is complicated problem, I understand. But no, I cannot solve an entire test. So some question that you have some problem, I try to help. Okay, guys, enjoy your